and welcome back to Algebra 1. Our goal for today is to look at a relationship that is called a function and be able to identify if a set of values or set of points or a graph is a relation that fits into a special category called a function. So some key things that we need to understand about a function. And we've looked at some, linear functions a little bit when we were doing our graphing, when we were given that function notation, like f of x equals or g of x equals. All right. So at this point, we should be able to evaluate for different values, like what is f of 3 or what is g of 5. And we should be able to graph linear functions when given f of x equals, when we have something like f of x equals 2x minus 3. So our goal for today is a slightly different goal than what we've already looked at with functions, which is how do we determine if something creates a function and what is the domain and the range of those particular relations called functions. So a function is a rule that establishes a relationship between two quantities. So typically for linear equations, right, those two quantities we refer to as the variables x and y. But we could replace those x's and y's with other letters or variables in the problem, like a's and b's and things like that, right? Where it's a comparison of those two values, where each of our inputs has exactly one output. So our input values, the set of numbers that create that input is called the domain. It is when we're using x's and y's, it is our x values. And the output values, what we get as like the answer, right, which would be the output values, is our y values of our set of numbers, which is called the range. So a function says that for each domain value, there's exactly one range value that it gets paired up to. Or for each input, there's exactly one output. We have two tests we can run to see if a relation of numbers or a set of numbers creates this special relationship called a function. So that's our goal for today. How do we run our two tests to see if a set of values is a relation or if it's a special relation called a function? So our two tests are called the mapping diagram test and the vertical line test. Go ahead, take a second here, fill in your blanks. I promise we're going to go through both tests and I will explain how to run them. All right, both of these tests accomplish the same goal. And the goal is if it passes either of these tests that we're going to look at today, then we have a special type of relation called a function. Or we could describe it as y is a function of x. Right? Those are the same thing. If it doesn't pass the test, then the set of values given to you, either in picture format or number format, are simply just a relation. So the way I think about this is I would think of like if I was at a family reunion, we're all related, right? We're all part of the same relation, but we might not be all having fun, meaning it might not be a function. So the test is to determine if the relation is a more specific category or a specific type called a function. And the way that we would describe that is it's a relation that is a function, or we could say that y is a function of x. So we're going to look at our first test here. And when we draw our mapping diagrams, this is what's going to look like, where we have input values being attached to our output values. So the way that the test works is you want to look at your input or your x values, right? Your output are your y values. And you want to look just at that set of numbers. So the test says for each input, there's exactly one output. So if I look at each of these inputs, do they only attach to one output, right? So this -3 attaches to one thing, which is the 0. So that's good. This 0 attaches to one output, so it's good. This 5 only attaches to one thing, the 0, it's good. And this 2 only attaches to one thing, so it's good. So the shortcut is in my input part of my diagram. Is there only one arrow attached to each number. If that's the case, then it passes the test and we would say that y is a function of x. Or the other way to say it is this mapping diagram represents a relation that is a special type called a function. So let's look at another one. All right, we're going to run our mapping diagram test. We want to look just at our x or input or domain part of our picture. All right, one arrow here, that's a pass. One arrow here, that's a pass. One arrow here, second arrow here, that's a fail. So in this particular example, the input value of 3 has 3 output values. That would be a fail, right? -2, 1, and 3 can only have one output that it's attached to. And so in this case, we would say y is not a function of x. Or these set of numbers create a relation, not a special relation that is also a function. So let's look at another one here. So we have this input value or domain value or x value. Those all mean the same thing. It goes to 1, 2, 3, 4 things. That's a fail. So in this case, we would say that y is not a function of x. Or we would say that this is not a relation that is a function. It's just simply a relation. So let's look at our examples in our packet. All right, we're given the set of numbers -1, -1, 2, 0, 3, 1, 5, 2, 6, 4. And we want to run the test to see if y is a function of x. If we would say yes to this question, y is a function of x, then it's this more specific thing, right? It's a relation that is a function. If y is not a function of x, then it's just simply a relation. Right? So let's run our test. We got to create our mapping diagram. So over here in our input, that's all of our x's. So remember, ordered pairs go x, y. So our inputs are -1, 2, 3, 5, and 6. And we always want to put our inputs there in numerical order. So this one's kind of nice. It's already in lowest to highest order for us. But if not, we would want to do that as we set them in here. All right, our output, this side is our y's, which are second in our ordered pair. So we have -1, 0, 1, 2, and 4. Again, in this case, they happen to be in numerical order for us, which is nice. So -1, 0, 1, 2, and 4. All right, now we're going to do what I call the sewing of the pickles, right? We're going to attach what goes with what. So this -1 goes to -1. So straight across here. 2 goes to 0. 3 goes to 1. Right, we're attaching them together. 5 to 2, and 6 to 4. And then once we have our mapping diagram drawn, we want to look over here at our x's. If each of those only has one arrow, then it is y is a function of x, or it's a relation that is a function. So -1, 1 arrow, 1 arrow, 1 arrow, 1 arrow, 1 arrow. Boom, this is a pass. Y is a function of x, which means this is a relation that is a function, right? Would be the correct conclusion to circle down there below. All right, follow-up question. Which points that are listed below could be added to this function and it remain a function? So the thing I want to look at here is if I were to add these over here into my diagram, remember, I can only have one arrow coming off a number here. So when I'm looking at my x's. I can't have duplicated x's. That's really the test. So if I added this ordered pair 1, 4, would we be okay? Yes, because there's no 1 already in the input. So we could add 1, 4. 3, 6. If I added that here, then this 3 would now go like this, jing, 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 to a 6, and that would be a fail. So we can't add that one. 0, 0. Sure, we can add a 0 here, right? Boop, right? We can have 1 arrow coming off a 0 here. It doesn't matter that there's 2 over here, so that's good. 2, -1. Well, that would make a second arrow happen here, and that would be a fail. So that's a no good. 10, 3. Yeah, we can add a 10 down here and a 3 over here, right? And we could attach. That wouldn't change anything. So that's a yes. All right, so 1, 4, 0, 0, and 10, 3 could be added to this set of numbers, and it would remain a function. All right, let's try another one. All right, number 2, we want to create our mapping diagram from our set of numbers, -2, -1, 0, 2, 2, 3, -2, -4, and 1, 3. All right, our x values first, right? Input is our x, output is our y. So -2, 0, 2, -2, and 1. So lowest number here, -2, then our 0, then 1, and then 2. Right? That would represent any values in our input. All right, same thing with our outputs or our y's. -1, 2, 3, -4, and 3. So -4 is the smallest right here. Then our -1 right here. Then 2, and then 3. All right, let's attach. Let's sew our pickles. So for this first one, -2 gets attached to a -1. This one, a 0 to a 2. This one, a 2 to a 3. This one, a -2 to a -4. Right now, I should be going, whoa, that -2 has 2 arrows. That's when this fails. So y is not a function of x, so this is just a relation. Since this right here has -2 has 2 outputs, it fails the mapping diagram, so this is just correlation. All right, number 3. Let's make our mapping diagram for our set of numbers -3, 1, 2, 5, 3, 1, 4, 2, and 6, 5, and see if we can draw the conclusion if y is a function of x or not. All right, let's start with our x's, our inputs. So -3 is our smallest right here. Then our 2, 3, 4, and 6. All right, our y's, 1, 2, and 5. All right, let's sew them pickles. -3 to 1, 2 to 5, 3 to 1. That's not a fail. This is not a fail. You're allowed to have 2 inputs going to the same output. You just can't have an input that goes to 2 different outputs. So be careful. This is still, we're passing still here. 4 to 2 for this guy and 6 to 5. All right, I only look at this. 1 arrow, 1 arrow, 1 arrow, 1 arrow, 1 arrow. That is a pass. So y is a function of x, which means this is a relation that is a special type called a function. And the reason is because each input goes to exactly 1 output. All right, so let's see, which ones could we add here? All right, in your head, make a list. Which ones? 1, 1, 3, 3, 0, 0, -7, 2, and 2, -4. Which ones could we add and this remain a function? All right, let's look. If there's no 1 already over here, it's good. So no 1s yet? Yep, we're good. All right, this 3 is no good. There's already a 3 here. Can't use it. 0, 0. There's no 0 over, right? There's no 0 already over here, so it's good. -7, 2, that's a good one we could add because there's no -7 yet. And then 2, -4 is a no-go because there's already a 2 up here. All right, so we could add 1, 1, 0, 0, and -7, 2, and this relation would remain a function. All right, let's look at our last one here, number 4. Let's make our mapping diagram here to see if y is a function of x. All right, -4, 2, 3, 6, 2, 3, 6. All right, 2, 3, 6. All right, let's go to -1, then our 1, then our 2, then our 3 here. 2, 2, 3, 1. All right, let's sew them pickles. All right, -4 to 2. Done. 2 to 3. Still a pass. 1 arrow, 1 arrow. 3 to 2. Still a pass here. That's not a fail. Everything has 1 arrow so far. All right, -4 to +1. All right, there's our fail. This -4 has 2 arrows. 6 to -1. So since right here there are 2 arrows, that means y is not a function of x, which means this is just a relation. It has failed the mapping diagram right here where -4 has 2 output values. So be careful. All right, so test number 2 is when we're given a graph instead of set of points, and we're asked if that graph represents a function or if y is a function of x. And the way you can tell that is if you could draw a vertical line anywhere in your graph, and it passes through the graph or any of the points of the graph in more than one place. That would end up failing the test. So I've given you an example here in your notes where it would pass a test, right? Each of the red lines represents the test we're running of drawing vertical lines to see if it passes our graph. All those red lines only go through one point of the that's in the picture. However, if, for example, let's say on I'll go to green here so it stands out. On this red line here, if there was a second point, that would be a fail, right? Where I have one vertical line that passes through the graph in two locations, then that would make this where it's y is not a function of x. So let's look at some examples here that aren't part of your packet. If I was given this picture, and this is the graph, right? The line here, not the axes, right? This guy right here is what we're looking at. That's the graph. We want to know if y is a function of x. And the way to tell is if we were to take a vertical line and go through the whole picture, is there any place where we could stop? For example, if I stop like here, am I crossing that graph in more than one place? If the answer to that question is ever yes, then it's a failed test. If we can't find a location where it fails that test, then y is a function of x. So we should be at the point where we understand linear relationships are always going to be functions except for one special case, and that's when our slope is undefined. So be careful. So we have y is a function of x here, and the reason is because it passes the vertical line test, which means this is a relation that is also a function. All right, so let's try another one here. If we're given this graph here, and it's a continuous curving. No, it looks a little bit funny. It looks a little disoriented. Let me add to here. This down here is just meant to be an endpoint, right? This is an endpoint, and this is just one. It just curves here, all right? So let's run our test and see if it passes the vertical line test. If it does, y is a function of x. If it fails in any location, then y is not a function of x, and this is simply a relation. So as I go here, I'd say, all right, we're good, good, good. But right here would be a great place to stop and look. We can tell that this vertical line is passing through this graph in multiple places. So right here and right here, right? That vertical line is hitting that graph in more than one place. And as long as I can show one place in that graph, now this graph we can show a whole bunch, right? We could go again, right? Like every spot here pretty much right here. Oh, now it's crossing here in two spots, right? As long as we can find a single location in the graph where a vertical line would go through that graph more than once, that would be a failed test. So for this particular case, y is not a function of x. So this would just be a relation because it fails that vertical line test. All right, so let's look at another one here. We want to see if this would pass or fail. Now, I'm going to go over here, and right now we're good. We're good, we're good, we're good. And it's right here where it seems like it's not good, right? And then we're good again over here. So a couple things to keep in mind here. This is actually a fail. And the reason this is a fail is because you have multiple places where the graph and that vertical line exists. So right here through here are all places of the graph. And so this vertical line is hitting that graph in all those locations all at the same time in one same continuous vertical line. If this piece wasn't part of the graph, right? If this middle piece here in the middle, if this middle here was not part of the graph, this particular graph would pass the vertical line test. And the reason is an open circle sets a boundary but doesn't really exist. So you have to be careful. Now this one, since that middle part is black in between there, it does fail the vertical line test. So you just have to look very carefully to see if it passes or not. So this one would be another example of failing the vertical line test, which means y is not a function of x, which means this is just a relation. And the reason being it failed that vertical line test. All right, so this one's a little bit different. It gives us discrete points. It's not a continuous graph. Instead, they're individual points like the one I gave you as an example in your by your definition. However, even when we're given discrete spots, discrete just means individual locations, I would still say, all right, at this point, am I only hitting one dot? Yes. At this point, just one dot? Yes. Just one dot? Yes. Just one? Yes. Just one dot? Yes. Don't use the axes there. We're just looking at the points of the graph. Yes, we're good. Yep, we're good. Yep, we're good. Yep, we're good. So nowhere on any of these points did we pass 2 points with the same red line. So this would be y is a function of x. And the reason being is it passed the vertical line test. So this is a relation that is also a function. All right, I will, again, I'm not sure why. I will fix the ends here. These are just, this has a closed-in circle here and a closed-in circle here, right? That's what it should be there. All right, so let's run our vertical line test here. Now, these are curves, so they're continuously moving a little bit. So we're good, 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 good. Maybe not good, 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 good. So our only point of question is right here, where it looks like we're going through what would be a closed-in circle and an open circle. Now, at first glance, we might say this fails because it looks like it's passing through the graph in 2 spots. But remember, an open circle, this circle here, doesn't exist. It's setting a boundary, but it's not really there. So the only part of the graph that's really here is this filled in circle. So that's a pass. This is good. This is a function. We should be saying y is a function of x here. And the reason is that it's a relation that is a function is because it passes the vertical line test. All right, so on your own, try the graphs that are in your packet and try to identify if they pass the vertical line test or not. And if they do, describe them as a relation that is a function. And if they don't pass the vertical line test, describe them as simply a relation. All right, hopefully you hit your pause here and you tried your 4 on your own. So let's look at them. All right, that first one is just a relation. The reason being is the vertical line test would fail here. It would also fail on this portion of the graph too, where it would hit this guy and this guy at the same time. So this is just a relation because it fails the vertical line test. So y is not a function of x. Number 2, passes the vertical line test. There's nowhere we could draw a vertical line and pass through the graph in multiple places. So y is a function of x, which means this is a relation that is a function. Number 3, again, yours looks like this with some endpoints here, so I'll go ahead and add that in. Again, this one fails the vertical line test. It fails in a whole bunch of locations. So I gave you this version here where it passes the graph here and here, but really, right, done, done, done. Like all these locations are going to fail the vertical line test. So this is not, y is not a function of x. It is just a relation. And then your last one here, it passes the test. The only place where we might be confused, again, is here where we think it goes through the graph in 2 spots. But since this circle is open, that means it's setting a boundary, but it doesn't really exist. So this is good. Now, if this circle had been closed in, that's a fail, right? That would have been a fail. But since this was an open circle, good to go. Good to go. Y is a function of x, which makes this a relation that is a function, and it passes the vertical line test. All right, that should help you attack your work for today. See you guys later.